Welcome to my channel. In the last video we have discussed about the basic designs of demultiplexer. So in this video I am going to explain the demultiplexer tree. So I am going to explain this demultiplexer tree with some examples. So design 1:4 demux, 1:4 demux using 1:2 demux. Okay, so design 1:4 demux using 1:2 demux. Okay, now I am going to design this 1:4 demultiplexer using 1:2 demultiplexer. So for that purpose, here our ultimate aim is what? 1 input and 4 outputs. So 4 outputs, that is equal to 2 power m, that is equal to 2 power 2. So m is equal to 2 selection lines are required for this one. Okay, so this 4:1 demux by using 1:2 demuxes. Okay, how many demuxes are required? For example, here 4 divided by 2, this 2, that is equal to 2 1:2 demuxes are required. We just draw the 1:2 demuxes first. Okay, here 1:2 demux, 1:2 demux. So what is the two outputs? So y0 and y1. Here y2 and y3. Okay, so totally 4 outputs. So 4 outputs. So here you are having 2 inputs. Okay, for the mux 1 in, for demux 1 input, and demux 2 and another input. So for these two lines you just combine another 1:2 demux. So here 1:2 demux. So here only one input and 2 outputs. So here for 1:2 demux, so you need one selection line. So you just take this selection lines for common selection lines. I am going to assume this selection lines as S0, and here one more selection line, that is S1. So based on this S1 only it is going to operate. Whether if S1 is equal to 0, this first demux is enabled. If S1 is equal to 1, the second demux is enabled. This is reverse process of demultiplexer tree, multiplexer tree operation, which is explained in the previous videos, right? Now here you just see the design. So single input and 4 outputs, y0, y1, y2 and y3, and 2 selection lines. Just take this as common selection lines S0. Okay, so based on this S1, so it is going to operate, that is the first demux, and if S1 is equal to 0, the first demux is enabled. If S1 is equal to 1, the second demux is enabled. Okay, so this type of problems are very important for competitive examinations, as well as what multiplexer tree also, it is very important for competitive examination. They are going to ask, okay, so for designing of 1:4 demux, using 1:2 demux, how many 1:2 demuxes are required for designing 1:4 demux? Like that they are going to ask questions. Here 3 1:2 demuxes are required. Okay, that is the answer. The same thing. So in the previous video I have explained multiplexer tree, that also. So how many multiplexers are required for designing, for example, how many of 4:1 multiplexer are required for designing 16:1 mux. Like that, that type of questions they are going to ask in competitive examinations. Okay, now I am going to explain one more design. So for example, I am going to explain here 1:8 demux using 1:4 demux. For example, 1:8 demux using 1:4 demux. Okay, so for this one, so here 1:8 demux is there, and 1:4 demux is there. Using 1:4 demux, you have to design this one. So 4 plus 4, 2, that is 8 divided by 2. Just calculate like this. 8 divided by 2, that is equal to, so 8 divided by 4. 8 divided by 4 is what? 2, 1:4 demuxes are required. But how many selection lines are required here? 8. 8 is equal to 2 power m, that is equal to 2 power 3. So m is equal to 3 selection lines are required for designing this 1:8 demux. Okay, now how many demuxes are required? That is 8 divided by 4, that is 2 demuxes, 1:4 demux. First we just draw the 1:4 demux, 1:4, and here also 1:4. So you will get what? 4 outputs, y0, y1, y2, y3, y4, y5, y6 and y7. Okay, totally 8 outputs are there. And here you are getting what? 2 inputs, one for first demux and another for second demux. For this you have to put another 1:2 demux. So 1:2 demux. Okay, here you will get one input. Okay, so D is one input and two outputs. Automatically it is connected to 1:4 demaxes, right? So for this, how many selection lines are required? For 1:4, 2 selection lines are required. So what are the selection lines here? I am going to assume these selection lines are S0 and S1. Take the input as S0 and S1 as common. For 1:2 demax, only one selection lines, that is S2. Right. So based on this S2 only it is going to operate. Based on this S2 only it is going to operate. If S2 is equal to 0, this first demax is enabled. If S2 is equal to 1, this second demax is enabled. So this type of the same procedure you have to follow for some other demultiplexers. Okay, you can try for, I am going to give some clues. You just try for 1:16 demax using 1:4 demax, or otherwise 1:16 demax using 1:8 demax. Okay, so many examples are there. So the procedure is same for all different types of problems. Okay, so hope you enjoyed this video. So if you like this video, so please subscribe, share and like this video. Thank you.